Hi there. So in this video, we will learn how to find the general solution of second order linear differential equations. We first take up the important special of case of homogeneous linear equations with constant coefficients. So the standard form of such equation is a y double prime of t plus b y prime of t plus c y of t equals to 0. So in the right hand side, the 0 indicates that the equation is homogeneous equation where a, b, and c are real constants. So the key idea in solving this equation is to look for solutions of exponential form y of t equals to e to the rt, where r is could be any constant, is a constant. Okay, so let us call our general equation, let us call it a equation star. Okay, so if we take a differential of both sides of this equation, so y prime of t equals to r e to the rt, and y double prime of t equals to r squared e to the rt. So let us substitute these terms into a equation star, the equation star, so then we'll get a r squared e to the rt plus br e to the rt plus c e to the rt equals to 0. So then we can take a common, so e to the rt can be taken as a common. So this implies e to the rt can be taken as a common term, ar squared plus br plus c equals to 0. So then, so of course e to the rt is not equals to 0, so then ar squared plus br plus c should equals to 0, and this algebraic equation is called a characteristic equation of the differential equation star. Okay, characteristic equation, equation of the differential equation star. So we know that this is nothing, just a quadratic equation. So the quadratic equation, so we can solve the quadratic equation as, so it has two solutions. Let me say r1 and r2 equals to minus b minus plus square root b squared minus 4ac over 2a. So of course a cannot be 0. Okay, so if we look at this expression, so we will have, or we will get three cases. So let us explain case 1. So in case 1, if the under square root b squared minus 4ac, if it is positive, so then if it is positive, so then we will get two distinct real solution. We'll get two distinct real solution. Let me say r1 and r2. So then the general solution of this differential equation is going to be y of t c1 e to the r1 t plus c2 e to the r2t, where c1 and c2 could be any real constants, any constant. constants. Okay, case 2. So if b squared minus 4ac is negative, so then we will get two complex solution, and sometimes it's called conjugate complex. So let me denote it by the solution is R1, R2, can be written as a form of complex form minus plus I mu, real part and imaginary part. So then the general solution of the original differential equation is going to be y of t equals to e to the real part lambda t and some constant, let me say again, c1, or let's say c3 a cosine mu t plus c4 sine mu t, where c3 and c4 are constants. Okay, so then the last case 3, if b squared minus 4ac equals to 0. Okay, so then in this case we will get a real repeated solution, real repeated solution. Let's say R1, okay, equals to R2, and let me say equals to some other R. Okay, so then the general solution of our differential equation star is going to be y of t equals to some constant, let us say c5 e to the rt plus c6 t e to the rt. Okay, so let us briefly review. So we will get, after we find the characteristic equation, so then we will get three cases. So in each case, so the general solution of our second order homogeneous linear differential equation is going to be, the general solution is going to be in this form, or this form, or in this form. And thank you. Please, if you take advantage from this video, please subscribe to support our channel. Thank you.